For today's video, we are going to have a practice problem on how to find the derivative of the given algebraic functions, and we are going to explain everything in details. So to find the derivative of algebraic functions, there are two things that we need to consider. So for example, if we are going to have the derivative of x raised to n, that will give us n x raised to n minus 1. Aside from that, if we are going to have the derivative of the derivative of constant is always equals to 0. So these are the things that we need to consider in order for us to find the derivative of the given algebraic functions. So let's start with the first example. On number 1, we have y equals 12x cubed minus 27x squared minus 8x plus 12. So let us have y prime, that is the derivative of function y, and we have dy or d over dx of 12x cubed minus d over dx of 27x squared minus the derivative of 8x plus the derivative of the constant 12. So to simplify this one, we have y prime equals 12 multiplied by 3, that is 36, and then we have x 3 minus 1 minus 27 times 2, that is 54, x squared minus 1 minus the derivative of 8x, that is 8x raised to 1 minus 1, and the derivative of constant, that is 0. So to simplify this one, we have y prime is equal to 36 x 3 minus 1, that is 2, minus 54 x 2 minus 1, that is simply 1, and then we have negative 8 x raised to 1 minus 1, that is 0, and then we are going to disregard 0. So we have here y prime is equal to 36 x squared minus 54 x raised to 0, that is 1. So we are going to have here negative 8. So therefore, this will be the derivative of the given function. On example number 2, we have y equals 4x raised to negative 5 plus 2x raised to negative 3 minus 4x raised to negative 2 plus x raised to negative 1 plus 3. So to find the derivative of the given function, let us have y prime equals the derivative of 4x raised to negative 5 plus the derivative of 2x raised to negative 3 minus the derivative of 4x raised to negative 2 plus the derivative of x raised to negative 1 plus the derivative of the constant 3. So to simplify, we have y prime and then 4 multiplied by negative 5, that is negative 20, x raised to negative 5 minus 1, and then we have 2 multiplied by negative 3, that is negative 6, x raised to negative 3 minus 1, minus 4 times negative 2, that is negative 8, x raised to negative 2 minus 1, and then we have 1 multiplied by negative 1, that is negative 1x raised to negative 1 minus 1, plus the derivative of constant, that is 0. So to simplify this one, we are going to have y prime equals negative 20 x raised to negative 5 minus 1 is negative 6. Positive times negative is negative. And then we have 6x raised to negative 3 minus 1 is negative 4. Negative times negative, that is positive. 8x raised to negative 2 minus 1, that is negative 3. And then positive times negative 1, that is simply negative x, or same as negative 1x raised to negative 2, and then plus 0, or we are going to just disregard 0. Since we have negative sign on the exponent, let us eliminate the negative sign by getting their reciprocal. So we have y prime equals negative 20 over x raised to 6 minus 6 over x raised to 4 plus 8 over x cubed minus 1 over x squared. So you can write your answer in this form, or if you want to combine all the numerators and denominator, we are going to have the LCM of the denominator. Since the highest exponent is x raised to 6, we are going to have x raised to 6 as their denominator, or the LCM of the denominator. X raised to 6 divided by x raised to 6, that is 1. And then multiply by negative 20, that is negative 20. And then x raised to 6 divided by x raised to 4, that is x squared, multiplied by negative 6, that is negative 6x squared. And then x raised to 6 divided by x cubed, that is x cubed, multiplied by 8, that is 8x cubed. And lastly, x raised to 6 divided by x squared, that is x raised to 4, times negative 1, that is negative x raised to 4. So, to simplify our answer, we are going to have y prime equals negative x raised to 4. We are going to write the given expression into highest degree down to the lowest degree. So, we have negative x raised to 4 followed by 8x cubed minus 6x squared minus 20 all over x raised to 6. So this will be our final answer. On example number 3, y equals 4 over 5 x raised to 3 over 7 plus 2 over 3 x raised to 3 over 5 plus x raised to 1/3 plus 3. So let us find the derivative of the given function. Let's start having y prime equals the derivative of 4 over 5 x raised to 3 over 7 plus the derivative of 2/3 x raised to 3 over 5 plus the derivative of x raised to 1/3 plus the derivative of the constant 3. So let us simplify. We have y prime, and let us multiply 4 over 5 by 3 over 7. So we can write this one as 4 over 5 times 3 over 7 x raised to 3 over 7 minus 1 plus 2/3 times 3 over 5 x raised to 3 over 5 minus 1 plus the coefficient of x is 1. So we have 1 times 1/3 x raised to 1/3 minus 1. And then the derivative of constant 3 is 0. So we have y prime equals 4 times 3, that is 12, over 5 times 7 is 35, x raised to 3 over 7 minus 1, that is negative 4 over 7. So the fastest way to simplify this one, let us simply have 3 minus 7 is negative 4 and copy the denominator of exponent, which is 7. And then, on the other side, we can cancel this one. This will give us 2 over 5 x raised to 3 over 5 minus 1, or simply 3 minus 5 is negative 2 over 5 plus 1 times 1 is 1 over 3, and then x raised to 1/3 minus 1, or simply 1 minus 3 is negative 2 over 3. And since we have negative sign on the exponent, we can get the reciprocal of this one to eliminate the negative sign. So we have y prime equals 12 over 35 x raised to 4 over 7 plus 2 over 5 x raised to 2 over 5 plus 1 over 3 x raised to 2/3. So you can write your answer in this form, or you can write the radical form of the denominator, that is y prime is equal to 12 over 35 seventh root of x raised to 4 plus 2 over 5 fifth root of x squared plus 1 over 3 cube root of x squared. So this will be our final answer. On example number 4, we have y equals 3 over 5, x raised to negative 2 over 3, plus 4 over 7, x raised to negative 5 over 3, plus 4 over 9, x raised to negative 3 over 5. So let us have the derivative of the given function. So let's start having y prime equals derivative of 3 over 5, x raised to negative 2 third, plus the derivative of 4 over 7 x raised to negative 5 over 3 plus 4 over 9, or the derivative of 4 over 9 x raised to negative 3 over 5. So let us simplify. We have y prime. So let us multiply 3 over 5 and negative 2 third. So let us start having 3 over 5 multiplied by negative 2 over 3 x raised to negative 2 third minus 1 plus 4 over 7 times negative 5 over 3 x raised to negative 5 over 3 minus 1 plus 4 over 9 times negative 3 over 5 x raised to negative 3 over 5 minus 1. So let us simplify this one. Let us have y prime equals, we can cancel 3. This will give us negative 2 over 5, and then x, negative 2 over 3 minus 1, that is negative 5 over 3. So again, the fastest way to simplify this one is negative 2 minus 3 is negative 5, copy the denominator 3. And then we have 4 times negative 5 is negative 20 over 7 times 3 is 21. X raised to negative 5 minus 3 is negative 8 over 3. And then we have 4 times negative 3, that is, or we can cancel 3 and 9. So 3 becomes 1 and 9 becomes 3. This will give us 4 times 1, that is negative because we have negative sign. 4 over 3 times 5 is 15. X raised to negative 3 minus 5 is negative 8 over 5. So let us simplify this one. And since we have negative sign, again, we are going to get the reciprocal of this one. So we have y prime equals negative 2 over 5 x raised to 5 over 3. Positive times negative is negative 20 over 21 x raised to 8 over 3. And then positive times negative is negative 4 over 15 x raised to 8 over 5. So again, we are going to write this one into radical form. So we have y prime equals negative 2 over 5 cube root of x raised to 5 minus 20 over 21 cube root of x raised to 8 minus 4 over 5 fifth root of x raised to 8. And then, to simplify this one, we can write this one as y prime equals negative 2 over 5. Since our index is 3, we are going to get the perfect cube inside the radical sign, which is x cubed. So this will give us x, or we can write as cube root of x cubed, and then x squared, because 3 plus 2, that will give us 5. And then later on, we are going to get the perfect cube, which is x cubed. And then we have 20 over 21, and our index is 3. We are going to divide the exponent of x by 3. So this is cubed, x cubed, x squared. And then on the other side, we have 4 over 5. This time our index is 5, and we are going to divide the exponent as 5. So x raised to 5 and x cubed. So to simplify, we have y prime equals negative 2 over 5. Since we only have one x cubed, we are going to have x and then cube root of x squared. So let us simplify this one. So we can write our answer. So I'm going to enlarge this one first. So we can have here y prime equals negative 2 over 5. And since we only have one x cubed, we are going to have x and then cube root of x squared minus 20 over 21. And since we have 2x cubed, we are going to have x squared. X squared, it indicates the number of perfect cube inside the radical sign. So this is cube root of x squared minus 4 over 5. And since we only have x raised to 5 inside the radical, so we are going to have x and then fifth root of x raised to 3. So therefore, this will be the derivative of the given function. On example number 5, we have y equals 4 over 7 x raised to 2 thirds plus 5 over 3 x raised to negative 4 over 5 plus 6 over 7 x raised to 2 over 5. So in order for us to simplify this one, let us move the variable x into the numerator. So this is y equals 4 over 7x. So if we are going to move this one on the numerator, it will give us negative 2 over 3 plus 5 over 3x. And this, since this is negative, it will give us positive 4 over 5 plus 6 over 7 x raised to negative 2 over 5. So let us find the derivative. Let us have y prime equals the derivative of 4 over 7 x raised to negative 2 thirds plus the derivative of 5 over 3 x raised to 4 over 5 plus the derivative of 6 over 7 x raised to negative 2 over 5. So let us simplify this one. So in order for us to simplify, let us just multiply 4 over 7 and negative 2 thirds, same thing as the other expression. So we have y prime equals 4 over 7 times negative 2 over 3, and then x raised to negative 2 thirds minus 1 plus 5 over 3 times 4 over 5, x raised to 4 over 5 minus 1, and then we have 6 over 7 times negative 2 over 5, x raised to negative 2 over 5 minus 1. So let us have y prime equals 4 times negative 2 is negative 8 over 7 times 3, that is 21. And then we have x raised to negative 2 thirds minus 1, that is negative 2, minus 3 is negative 5. Copy the denominator 3. And then let us have, or we can cancel 5. This will give us 4 over 3. X raised to 4 over 5 minus 1, that is negative 1 over 5, or 4 minus 5 is negative 1. Copy the denominator 5. And then we have 6 times negative 2 is negative 12 over 7 times 5 is 35. and then x raised to negative 2 pip minus 1, that is negative 7 over 5, or negative 2 minus 5 is negative 7 over 5. So to simplify this one, let us have y prime, and then since we have negative sign on the numerator or the exponent, we can get the reciprocal of this one. So this will give us negative 8 over 21 x raised to 5 over 3, and then we have 4 over 3 x raised to 1 over 5 minus 12 over 35 x raised to 7 over 5. And let us convert this one into radical form. So this is y prime equals negative 8 over 21 cube root of x raised to 5 plus 4 over 3 fifth root of x raised to 1 minus 12 over 35 fifth root of x raised to 7. So to simplify, since our first index is 3, this will give us 5. Okay, so we can divide x raised to 5 as x cubed and x squared, because our index is 3 and we are going to get the perfect cube inside the radical sign, in which is x cubed. So we are going to simplify this one later. And then we have 4 over 3 fifth root of x minus 12 over 35. And this time our index is 5. We are going to divide or cut the exponent by 5, and that is x raised to 5 and x squared. So let us have y prime equals negative 8 over 21. And since we only have one x cubed in the radical sign, so we are going to get this one, and that is x, and then cube root of x squared plus 4 over 3 fifth root of x minus 12 over 35. We only have x raised to 5, which is the index is 5. So we are going to have x and then fifth root of x squared. So therefore, this will be the derivative of the given function. On example number 6, we have y equals 4 cube root of x squared plus 5 over 4 fourth root of x plus 2 over 3 fifth root of x raised to 4. So to simplify this one, we need to write the radical form into exponential form. So we have here y equals 4 x raised to 2 over the index, which is 3, plus 5 over 4 x raised to 1 over the index 4, plus 2 over 3 x raised to 4 over 5. So let us find the derivative. We have y prime equals derivative of 4x raised to 2 third plus the derivative of 5 over 4 x raised to 1 fourth plus the derivative of 2 over 3 x raised to 4 over 5. So let us have y prime. So let us multiply 4 and 2 third as 4 times 2 third x raised to 2 third minus 1 plus 5 over 4 times 1 fourth x raised to 1 fourth minus 1 plus 2 over 3 times 4 over 5 x raised to 4 over 5 minus 1. So we have y prime equals 4 times 2 is 8 over 3 x raised to 2 third minus 1, that is negative 1 over 3, or negative or positive 2 minus 3 is negative 1. And then we have 5 times 1 is 5 over 4 times 4 is 16. X raised to 1/4 minus 1, that is negative 3 over 4. Or simply 1 minus 4 is negative 3, copy the denominator 4, plus 2 times 4 is 8 over 3 times 5 is 15. X raised to 4 over 5 minus 1, or 4 minus 5, that is negative 1 over 5. And since we have a negative sign, let us write this one on the denominator. Y prime equals 8 over 3 x raised to 1/3 plus 5 over 16x raised to 3/4 plus 8 over x, or 15 x raised to 1/5. And since our given is written in radical form, we can simplify this one as y prime equals 8 over 3 cube root of x plus 5 over 16 fourth root of x cubed plus 8 over 15 fifth root of x. Since we don't have perfect cube, perfect fourth root, or perfect fifth root on the radical sign, we can write our answer in this form. On example number 7, we have y equals 3 over cube root of x raised to 5 plus 4 over 5 fourth root of x raised to 7 plus 3 over 2 fifth root of x raised to 2. So in order for us to simplify this one, we need to convert the radical form into exponential form and rewrite it on the numerator. So to simplify this one, let us rewrite the radical form into exponential form. This is 3 over x raised to 5 over 3 plus 4 over 5 x raised to 7 over 4 plus 3 over 2 x raised to 2 over 5. So to simplify this one, let us rewrite the variable x in the numerator. Since we have positive, we are going to have negative this time. So this is 3 x raised to negative 5 over 3 plus 4 over 5 x raised to negative 7 over 4 plus 3 over 2 x raised to negative 2 over 5. So let us find the derivative. We have y prime equals derivative of 3 x raised to negative 5 over 3 plus the derivative of 4 over 5 x raised to negative 7 over 4 plus the derivative of, let us rewrite this one as derivative of 3 over 2 x raised to negative 2 over 5. So to simplify this one, let us write as y prime equals, to find the derivative, let us multiply 3 by negative 5 over 3. So we have 3 times negative 5 over 3 x raised to negative 5 over 3 minus 1 plus 4 over 5 times negative 7 over 4 x raised to negative 7 over 4 minus 1 plus 3 over 2 times negative 2 over 5 x raised to negative 2 over 5 minus 1. So to simplify this one, let us have y prime. We can cancel 3. This will give us negative 5 x raised to negative 5 over 3 minus 1, that is negative 8, or negative 5 minus 3 is negative 8, copy the denominator 3. And then we can cancel 4. This is negative 7 over 5 x raised to negative 7 over 4 minus 1, that is negative 11 over 4, or negative 7 minus 4 is negative 11, copy the denominator 4. And we can cancel 2. This will give us negative 3 over 5 x raised to negative 2 over 5 minus 1, that is negative 7 or simply negative 2 minus 5 is negative 7 over 5. So let us eliminate the negative sign on the exponent. So we have y prime equals negative 5 over x raised to 8 over 3 minus 7 over 5 x raised to 11 over 4 minus 3 over 5 x raised to 7 over 5. So in order for us to simplify this one, let us write this one into radical form. So we have y prime equals negative 5 over cube root of x raised to 8 minus 7 over 5 fourth root of x raised to 11 minus 3 over 5 fifth root of x raised to 7. On the first expression, since our index is 3, we are going to cut x raised to 8 by exponent 3 because our index is 3. So we have y prime equals negative 5 over cube root of x cubed, x cubed, x squared. So if you're going to add up the exponent, it will give us 8 minus 7 over 5. And this time our index is 4. So we are going to cut the exponent 11 by 4, x raised to 4, x raised to 4, and then x cubed minus 3 over 5. This time the index is 5. So let us cut 7 by 5. So that is 5 and 2 because our index is 5. So to simplify this one, we have y prime equals negative 5. And since we have 2x cubed, which is perfect cube, inside the radical sign, it will give us x squared cube root of x squared minus 7 over 5. Since we have 2x raised to 4, that is x squared. The squared, it indicates the number of perfect fourth root inside the radical sign. So we have fourth root of x cubed minus 3 over 5. And since we only have 1, x raised to 5, this is x raised to 1 or simply x fifth root of x squared. So therefore, this will be the derivative of the given function. So I hope you've learned from this video. Thank you so much for watching and God bless us all.